Everyone, welcome to the solution of LeetCode problem 207 named course schedule. In this problem, there are total of n courses you have to take which are level from 0 to n-1. Let's consider number of courses is equal to n. Now, you are given a array of prerequisite where the prerequisite of I is equal to A of I and B of I indicates that you must take course B of I first if you want to take course A of I. Now, for example, the pair 0 and 1 indicates that one should take the course 1. After that, he can take the course 0. Or we can say that to take the course 0, you have to first take the course 1. That means course 0 is dependent on the course 1. Now, return true if you can finish all of the courses, otherwise return false. Now, let's consider the first example. Here, the number of courses is 2 and the dependency is course 1 is dependent on the course 0. So here it is possible that if someone finishes the course 0, after that he can finish the course 1. So in this way, they can finish 2 of the courses. Now, in the second example, the number of courses is 2, but the prerequisite are the course 1 is dependent on the course 0 and the course 0 is dependent on the course 1. So there is a deadlock. So it is not possible to finish both of the courses, so we have to return false. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, let's take this example. So here, to finish the course 2, someone have to finish the course 1. To finish the course 9, someone have to finish the course 2 and 1. And to finish the course 7, someone have to finish the course 5, 2 and 1. These are the dependencies, right? Now the question is, how can we solve this problem? We can easily solve this problem by using the topological sort Kahn's algorithm. So before jumping into the Kahn's algorithm, let's see why we use the topological sort intuition. The first intuition comes into our mind that here we are given some of the dependent tasks. Suppose to finish course A, we have to finish course B. That means course A is dependent on the course B. And if in any kind of graph problem, there is a dependency, something like that, those kind of problem basically can be solved using the topological sort, and you can use the Kahn's algorithm. Now, let's see in which case we cannot complete all of the course. Suppose we have course A here. It is dependent on the course B, and we have course B here. It is also dependent on the course A. Now, there is a cycle in a directed graph. That means it is not possible to finish any of the course because both of them are dependent on each other. So here, if any of the subgraph have the cycle, we can say that those kind of courses cannot be finished. So here, this problem can be solved in two ways. Either you can detect a cycle in a directed graph, and if the cycle exists in the directed graph, simply decide that we cannot complete all of the courses. Otherwise, we will use topological sorting and we will check whether we can complete all of the courses or not. So here, to understand the algorithm, we have chosen the topological sorting, and topological sorting basically based on the in degree of a graph, and in degree is the number of edges connected or coming towards a node. Suppose for this node 9, It's in degrees 2 because 2 of the edges is coming towards 9. So we will use the BFS to start the algorithm. Now at first, in the BFS queue, as we know that BFS utilizes the queue data structure, we will store the nodes which has the in degree of 0. That means here there are 3 nodes which has the in degree of 0, which is 1, 3, and 6. So here we should finish this 1, 3, and 6, these 3 courses, because these 3 courses is not dependent on any other. Now let's finish the course 1, 3, and 6. Now after that we have finished the course, we will erase the outgoing edges from this course. Now, as well as we will remove it. So 1, 3, and 6 is removed. Sorry, there is one edge. It should remain same. Now, what is the node which has the in degree? The node 4 and 2 has in degree of 0. So here we will visit the node 4 and 2 and remove the connection outgoing to the 4 and outgoing to the 2. So let's erase 4 and 2 here. Now which node has the in degree of 0 here? The node 8 and 5. So we have to visit the node 8 and the node 5, and we will remove all of the edges outgoing from this node. 8 does not have any of the edges, and 5 has 2 of the edges, so we will remove it. Now 5 is removed. Now we have 2 of the node in the graph which has the in degree 0, which is 9 and 7. So we have to visit both of them, 9 and 7 here. Now after visiting 9 and 7, we have to remove them from the graph as well. Now here we have seen that in the topological sort, we have visited all of the node in the given directed graph. And this is the valid topological sort order. So here we can decide that by using the Kahn's algorithm, in this graph, we can visit all of the node by using the topological sort. Hence, we decide that it is possible to complete all of the courses. Otherwise, if this graph has a cycle, it is not possible to visit all of the node, because in this case, if the graph has the cycle, the in degree will never be equal to 0. So in those kind of cases, we have to return false. That means it is not possible for us to complete all of the courses for this scenario. I hope you understood the algorithm and how basically the BFS works here. Basically here BFS works in the level by level manner. In each of the level, we will take the nodes which has the in degree 0. I hope you understood the algorithm. Now let's move on to the code. In this problem, to understand the code, we have taken the function which is canFinish, which has integer n and a vector of prerequisites. Now we are taking a vector named in. Now here initializes the vector named in of size n equal to 0, and we are taking another vector named completed course. Now we are taking a adjacency matrix or adjacency list. Now to implement the BFS, we are taking a queue of integers. Now for each of the element in the prerequisites, we are increasing the in degree of the first element of each of the element, and we are building the adjacency list. That means adjacency of or iterative or iterator of 1, pushback iterator of 0. Now we have to scan each of the element, and if any of the element has in degree 0, we have to push it into the queue to start the BFS. Now here in the BFS, while the queue is not empty, we have to store the front element of the queue into a variable current, and we have to insert it into the completed course. Now we have to remove it from the queue as well. Now for each of the children of the front element, we have to decrement their in degree because the edge is removed, and if any of the children's in degree is equal to 0, that means we have to insert it into the queue because those child can be used in the next iteration of the BFS. And finally, if the size of the completed course is equal to n, that means if we have completed or visited all of the nodes, that means we have completed all of the courses, we have to return true. Otherwise, we have to return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.